What if I told you that deep beneath Antarctica's ice, there are waves that haven't moved for centuries, not made of water, but frozen into solid, swirling sculptures? Picture the Southern Ocean, a violent, storm-ravaged sea where waves tower like mountains and winds scream across endless gray water. Now imagine one of those waves, at the very moment it crests, suddenly freezing solid. Not just the surface, but the entire wave, from its deep blue trough to its white-capped peak, turn to ice in a single, impossible instant. This isn't a scene from a fantasy novel. This is what scientists are finding beneath Antarctica's ice shelves. Structures so perfectly wave-like that they defy everything we thought we knew about how ice forms. For centuries, we've seen Antarctica as a flat, white desert, a frozen wasteland where nothing moves but the wind. But beneath that featureless surface lies a world more dynamic and mysterious than we ever imagined. A world where water doesn't just freeze, it remembers. To understand how waves can freeze, we need to journey to the edge of the continent, where ice meets ocean. Here, massive ice shelves, floating extensions of glaciers, extend far out over the water. Beneath them exists a hidden realm where seawater circulates in slow, cold currents. Normally, when seawater freezes, it forms flat, featureless ice. But under certain conditions, something extraordinary happens. The secret lies in what scientists call marine ice. Ice that forms not from the air above, but from the water below. Unlike freshwater ice, which freezes from the surface down, marine ice accretes slowly onto the underside of ice shelves. It grows in layers, sometimes just millimeters per year, capturing the shape of the water it formed from. Now, imagine a storm passing over the Southern Ocean. Powerful waves travel through the water, their energy reaching deep beneath the ice shelf, where the underside of the ice is especially cold. Often near the point where the ice shelf meets the bedrock, supercooled water forms. This is water that's colder than its freezing point, but hasn't turned to ice yet. When this water encounters the rough, irregular bottom of the ice shelf, it suddenly freezes, capturing the motion of the water at that exact moment. The result isn't just lumpy ice. Using radar and underwater robots, scientists have discovered formations that mirror ocean waves with astonishing precision, curved troughs and crests, even the foamy texture of breaking waves preserved in solid ice. Some of these frozen waves measure hundreds of feet from trough to crest, larger than most buildings, and they've been frozen in place for thousands of years. What's even more remarkable is that these structures aren't random. They follow patterns that match ocean cycles we can observe today. The spacing between frozen wave crests corresponds to common storm wave periods. The angle of their faces matches prevailing current directions. They're essentially fossilized oceanography, a permanent record of ancient seas that we can read like a history book. But the mystery deepens when we consider the scale. In some locations, these frozen waves form elaborate systems, what researchers call inverted landscapes, where the underside of the ice shelf mirrors the ocean surface above. There are frozen ripples, standing waves, even what appear to be captured turbulence from ancient eddies. The most spectacular formations occur where underwater currents were particularly strong, creating frozen wave trains that stretch for miles beneath the ice. The preservation is so perfect that scientists can determine not just how big the waves were, but what the weather was like when they formed. The texture of the ice, whether it's clear or filled with tiny bubbles, reveals if the water was calm or turbulent. The presence of certain minerals tells us about ocean temperatures. Even the direction of crystal growth shows which way the current was flowing. What emerges is a picture of an Antarctica that's constantly communicating with the ocean beneath it, recording every storm, every current shift, every temperature change in exquisite frozen detail. These aren't just beautiful formations. They're climate archives that could help us understand how our oceans have changed over millennia. The implications are profound. If we can read these frozen waves correctly, they might reveal patterns of ancient storms that could help predict future climate behavior. They might show us how ice shelves responded to past warming periods, crucial information as our climate changes today. Most importantly, they remind us that even in Earth's most remote corners, nothing is ever truly still, not even ice. What other frozen mysteries do you think are waiting to be discovered beneath the ice? Share your thoughts in the comments below, and subscribe to Nature Unlocked to explore more of Earth's hidden wonders with us.